Hi there. In this lesson, we're going to look at solving equations, but basic one-step equations. We're going to use the balancing technique as well to do it. So the balancing technique gets you to try and imagine your equation, which is up here, as a set of scales. So each side of the equal sign is represented by one of the scales on each side here. And whatever you do to one side on the scales, to keep it balanced, to keep it equal, you've got to do to the other side. So for example, if I put 1 on this, I've got to do the same to the other side to keep it balanced. And if I take away 1 from this, I've got to do the same to the other side, take away 1 from the other side. So this is in essence how to balance equations. Think of them as a set of scales. And we always want to keep them level because we've got an equal sign here in the middle. So one side of the scale must equal the other side. So the blue part here is x, and that's what we're trying to work out. We're always trying to solve the unknown. It can be an x, it can be any letter of the alphabet. In order to do that, we need to remove the 2 yellow bits to get x on its own. So we'll take away 2 from this side, and that means to keep it balanced, we've got to take away 2 from the other side. So I'll take away 2, and I've got it balanced. So that leaves me with x on its own, and the answer on the other side, which is 1, 2, 3, 4, 5. Obviously, you're not going to draw scales in your jotter and things like that. So what you would do is you would write it out like this. Again, what we tend to do is line the equal signs up. And in order to show what I did there, I took away 2 from this side. I'm going to put a wee take away 2 underneath. And I had to take away 2 from the other side. So I'm going to put a wee take away 2 from the other side. And that left me with the x here, or the blue bit. So I write x here, trying to back-to-back c's for x's, not crosses, because you look at times signs. On the other side, we started with 7 and we took 2 away. Started with 7, took 2 away, and your answer is 5. Okay, let's look at that idea. And eventually you want to get away from the scales, but let's look at that idea a couple more times. Now, these are algebra tiles. Your school might have them. They become quite useful. I'll just kind of try and show how they work here. So we've got x and 5 on one side, and we've got 9 on the other side. So to get x on its own, I've got to kind of remove the 5. I've got to remove the 5 here. Now, what we tend to do with algebra tiles is you kind of pair them up with the negatives, and they cancel each other out and get you to 0. So that will cancel out that, that will cancel out that. So I'm just taking away 5, if you like, with the algebra tiles. Here's another one, and taking away 5. Okay, and what happens is that it disappears, and I'll just delete that to show that. Except I've got to do the same on the other side. I've got to take away 5, so you cancel them out with the minus 1s. There you go. Take 2, take 3, take 4, and take 5. Okay, and that would cancel all of that out, and I'll delete that. Now, to represent that down here, what you would do is you just put a wee take away 5 under there, and a wee take away 5 under there, and you would get your answer of x equals 4. And you can see it there, x is equal to 4. Line up your equal signs when you're doing this. Now, when you've got a takeaway, then to cancel the negatives out, if you like, you get x take away 3, you put pluses in, and that cancels them back to 0, if you like. So you put pluses in, so you plus, 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 and that will cancel that out, and you can get rid of them. But I've got to do the same to the other side, haven't I? I've got to add 3. 1, 2, 3, and I'll get my answer. So I'm trying to get x on its own. Okay, in order to represent that in your jotter, if you like, you would put a wee plus 3 here and a plus 3 here. So that leaves me with x there. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 11 add 3. Now you can basically get to the idea of this without actually the pictures. If there's a plus 5, we took away from 5 from either side. If there's a take away 3, you added 3 to both sides. Now you can check to see if it works by putting it back in. Is 4 plus 5 9? Yes. Is 14 take away 3 11? Yes. Okay, let's try it without the algebra tiles. So here's another thing. The equation can look like this. You don't need the x over here. You can have it there, but use the same idea. You want to get the x on its own, and I've got 8 things next to it, so I want to take the 8 things away. But I've got to do the same to the other side. That's going to leave me with x on its own. and I took away 8 off 10, and that's going to give me an answer of 2, and that's your final answer. Does 8 plus 2 make 10? Yes. Now you can also get negative numbers. Okay, but let's just treat it the same way. We've got x minus 1 equals minus 7. So think about that wee bit up here. When you did a minus at 1, you brought in a plus, didn't you? So let's add 1 to cancel them out if you like, and add 1 to the other side. Now that's going to get you to x. And if you add 1 to negative 7, just be careful with that, you get to negative 6. Okay, a last wee note on this. You can see equations the other way around with x on this side. And you would just do the same thing. We already know that this looks exactly like the one up there. We've got 8 plus x equals 10. We've got 10 equals 8 plus x. All I would do is I would take away 8 from both sides, take away 8, and then you're left with the x over here, and you've got 2 over here. Okay, now the only thing I would ask is switch it around. Instead of saying 2 equals x, we tend to write x equals 2.